You know how so many people, super smart people, will just say, oh, I'm not a math person. Well, what if the problem isn't them, and it's not even the math? What if the real problem is the word understanding itself? Okay, let's get into this, because it turns out a paper from almost 50 years ago by a psychologist named Richard Skemp holds the key to this whole mystery.
So, to get our heads around this, we actually need to start with a little language trick, one that can cause a whole lot of confusion. And it's a concept that the French have the perfect name for.
Yeah, the term is faux amis, which literally means false friends. These are words that look or sound the same in two different languages, but whoops, they mean completely different things. They kind of trick you, right? They make you think you know what's going on when you really don't.
Just look at these examples. You can see how easy it is to get tripped up. In French, an histoire is just a story. But in English, history is supposed to be, facts. And you'd get into some serious trouble if you tried to borrow a book from a French libraire because that's a bookshop, not a library. These false friends create a total mismatch.
Okay, so here's where it gets really interesting. What if this exact same problem is happening in every single math class? Not between French and English, but between two hidden ideas packed inside the same word. What if the biggest false friends of all are words we use every day in school? Words like understanding in mathematics.
So, let's go investigate these two hidden meanings. Richard Skemp gave them very specific names, and trust me, when you see them side by side, it is a total light bulb moment. Okay, so on one side, you've got what Skemp calls instrumental understanding. I love his description for it. Rules without reasons. It's basically just having a recipe and knowing how to follow it to get an answer. But on the other side, that's relational understanding. This is knowing what to do and, more importantly, why you're doing it. It's all about seeing the big picture, how everything connects. And here's the kicker. For a ton of students and even some teachers, that first one, the checklist, is what they think understanding means.
Skemp paints this perfect little scene from a classroom. A teacher gives a formula, a student says, oh, I see, and suddenly they're getting all the answers right. By their definition, they get it. They have the rule, they can use it, but do they have any idea why length times breadth gives you the area? Maybe, maybe not. And this is everywhere, right? Think back to when you were in school. Did anyone ever really explain why you turn it upside down and multiply to divide fractions? Or was it just a magic trick you had to memorize to pass the test? These are perfect examples of instrumental learning out in the wild. So what happens when you've got these two completely different ideas of understanding clashing in the same classroom? Well, according to Skemp, you get chaos. Skemp's analogy for this is just brilliant. Imagine two teams agree to play football. One team shows up ready for soccer, the other team is in full gear for rugby. They're using the exact same word, football, but they're playing totally different games. The rules are different, the goals are different, and pretty soon each team is just looking at the other like they're either cheating or completely insane. And that's exactly what's going on in a math class. The student's goal is instrumental. They're thinking, come on, just tell me how to do it, I have a test on Friday. But the teacher, their goal is relational. They're trying to explain the deep connections, saying, but I really want you to see why this works. They're talking right past each other. Total frustration on both sides. Okay, if the football analogy wasn't enough, Skemp has another one that, for me, just perfectly nails the feeling of learning math in these two different ways. So, instrumental knowledge, that's like getting a list of turn-by-turn directions. Turn right out of your door, go past the church, take a left at the post office. It works. It gets you where you need to go. But it only gets you to that one specific place.
And here's the huge problem with just having directions. You make one wrong turn, maybe a road is closed, and you are totally, completely lost. You've got no idea where you are, no idea how to fix it, because all you have is that one rigid plan.
Now, relational learning, that's like having a mental map of the whole city. You don't just know one route. You get how all the streets fit together. You can figure out your own routes, find shortcuts, and if you hit a roadblock or take a wrong turn, no big deal. You just look at your mental map, figure out where you are, and find a new way to get there. It's empowering. You're in control.
Okay, so it sounds obvious, right? The map is way better than the directions. But let's play devil's advocate for a second. Skemp is fair about this. He asks, are there any upsides to the instrumental way?
So let's break it down. Look, the instrumental approach, it has its perks. It's often easier to grasp at first, and the reward, getting the right answer, is immediate. Feels good, right? But then you look at the relational side. The advantages are just huge, and they're long-term. It's way more adaptable for new problems. It's so much easier to remember. And get this, the act of understanding becomes its own reward. It actually makes you want to learn more.
Okay, so all of this brings us back to where we started. This conflict between the map and the directions is so deep, so fundamental, that Scamp comes to a pretty shocking conclusion.
This is the big reveal. Skemp's final take is that we're not even talking about two different ways to teach math. We're talking about two completely different subjects that just happen to share the same name. You've got instrumental mathematics, the science of memorizing rules, and you've got relational mathematics, the science of understanding connections.
And this isn't just some academic debate. The stakes are massive. The physicist Sir Hermann Bondi put it perfectly when he said that this negative attitude toward math is a real danger to our society. I mean, think about that. When we push people away from this fundamental way of thinking, we all pay the price.
So now we can finally solve the mystery. The math that so many people hate, the math they feel they're bad at, it isn't really mathematics at all. It's instrumental math. It's a boring, disconnected list of rules to memorize for a test. That's the false friend they met in school.
So I'll leave you with this question to think about your own experience. The way you learned, what were you actually given? Was it a map, this beautiful interconnected world you could explore forever? Or was it just a list of directions? The answer to that, well, it might just change the way you think about math and maybe even yourself forever.